my background is sort of civil, environmental, and engineering and hydrology. Have degrees in civil engineering from UC Davis and a master's in environmental from University of Florida and a doctorate in environmental science and engineering from UCLA. And then I worked for 18 years for U.S. Geological Survey in California. And I also worked for 12 years for the state of California, both the Water Resource Control Board and Department of Water Resources. So looking at kind of the water quality regulatory end and the water supply end of things. And for about the last 5 to 6 years, 5 years, I believe, I've been on the Environmental Technical Advisory Committee for Bainbridge Island. And the last couple of years, I've been the chair. And one thing that we were asked to do in ETAC was to put together a recommendation for developing a groundwater management plan for the island, and basically a budget and a time frame for what that would entail. So I'm going to talk about water sustainability, which can mean a lot of different things. I mean, to a lot of people, water sustainability is merely, is there enough drinking water? But it also means things for, like for fish and aquatic organisms that depend on water. And various types of habitats, wetlands and whatnot, obviously depend on the interconnection of groundwater and surface water. So as far as water sustainability, I'm going beyond, is there enough drinking water for Bainbridge Island? Because to me, that's kind of a limited scope of defining water sustainability, because it's about more than just us, really. So my talk outline is, first off, what is groundwater and what is seawater intrusion? Since being on an island, seawater intrusion is always going to be an issue of interest here. Then what is the Environmental Technical Advisory Committee and what do we do and who are we? And then talk about Bainbridge Island groundwater specifically, and then get into a couple of USGS models of Bainbridge Island groundwater, which have been done in the last 10 years, a couple different models. Then look at water budget analysis of Bainbridge Island groundwater. Where's it come from and where's it go? And lastly, yeah, I gave this talk back in January, pre-COVID, actually at the BPA theater up on stage. A much different way to give a presentation than sitting in your office. But back then it was fresh from having a Bainbridge Island Review article front page about Bainbridge Island groundwater and how everything is just fine. So I have some comments about that article, which interestingly enough, no one actually disputed in any way. But shortly after the article, everything became COVID. So, and then last, questions. And if you have any questions while I'm going along, please interrupt and ask at any time. I can't see you, unfortunately, but just jump on in. So what is groundwater? So this is sort of a USGS definition from their information for schools. So it's sort of written for maybe the 9th, 10th grade level understanding, which is probably pretty good for public information. This is basically what we're putting in our groundwater fact sheet, which we've been asked to do as kind of a kickoff to the groundwater management plan. So we've been putting together a 4-page groundwater fact sheet on basically what we think is known about groundwater on Bainbridge Island. And so groundwater is basically the water that exists underground in saturated zones under the land surface. The upper surface of this is called the water table. And contrary to some popular belief, it doesn't generally form underground rivers. It can sort of in karst areas where you get a lot of water flowing underground, but in general, it moves more slowly. Groundwater fills pores and fractures in underground materials, much the same way that water fills a sponge. If groundwater flows naturally out of rock materials, or if it can be removed by pumping, those materials are called an aquifer. Groundwater generally, of course, like surface water, flows from higher levels to lower levels. So instead of going from uphill to downhill, it goes from higher water levels to lower water levels, typically at rates of 3 to 25 inches per day. So as a result, water could remain in an aquifer, anywhere from weeks to months to hundreds to thousands of years. And aquifers are separated by layers of soil or rock, which are called confining layers. And groundwater quantity is estimated by measuring water levels. And those vary seasonally due to rainfall and groundwater pumping. So the best way to really see long-term changes in water levels is to measure at the same time of year after year, to really compare apples to apples. Seawater intrusion is where seawater can be drawn into near shoreline wells if groundwater is overpumped. This little schematic over here. Can everyone see my mouse? Moving around and highlighting things? Yes?
Yes, they can see your mouse, absolutely.
So over here you have a near shore well, irrigation well, and here you have a well that's, so this one's pumping some groundwater, it's lowering the water table in the vicinity of the well, and this one's pumping a lot more, and it's closer to shore, and it's actually pumping so much that it's pulling seawater into the well, and that's what's known as seawater intrusion. And of course, that could be a concern when you're living on an island and you're surrounded by seawater. So the city checks for potential seawater intrusion by monitoring chloride as a surrogate for seawater. Historically, it hasn't been a big problem on Bainbridge Island, but it's always something to be concerned about. And the more that you have groundwater pumping on an island, the more potential you're going to have for seawater intrusion. And this last little thing is a nice little physical fact about freshwater land sits on top of seawater due to differences in density between freshwater and seawater. So for every 1 foot of groundwater that you're above sea level, there's the groundwater extends for 40 feet below sea level. So every foot here is equal to 40 feet there below that the sea level. So if you lower the water table 1 foot, it extends down 40 feet. Whoa. Okay. So what is ETAC? ETAC is the technical advisory committee to the city council and the city manager and planning department on issues of environmental management. It was established as a temporary committee in 2001 and became permanent in 2009. Members are written in the code as required to have certain areas of expertise, including wildlife management, fisheries management, geology, wetlands, hydrology, forestry, and aquatic or terrestrial ecology. And who is on ETAC currently? We currently have 7 members, and we have 2 vacancies at the moment. So if anyone is interested or knows someone who might be interested in volunteering on a committee to advise the city council on environmental issues on the island, let them know. And they could contact, I guess, Roz Lassoff at the city and send in an application, or Christy Carr is our city council liaison for ETAC. So here's sort of the backgrounds of the people. The first person is me, hydrology background, and then we also have a hydrogeologist on the island, and an ecological design person who deals with green infrastructure, urban ecology, ecological restoration. We have a straight geologist, a licensed geologist who works with environmental remediation and closure at sites, contaminated sites. We have an environmental engineer working with environmental restoration projects. A geochemist who just joined us, who I saw on the call there a moment ago. He's also has background in environmental microbiology, geology, statistics, working with big data sets. We also have an environmental lawyer who also has a master's in oceanography, who's a retired NOAA lawyer on fish protection and ocean licensing projects. So that's the expertise that we have on ETAC currently. Bainbridge Island groundwater. So Bainbridge Island has 6 different aquifers that exist in various locations around the island. I mean, groundwater is kind of like a wedding cake, but all the layers are not continuous throughout the island. So some places may have 3 or 4 aquifers, other places 5 or 6, other places maybe just 1 or 2. But They're not continuous horizontally across the island, but here's a cross section of some of the what the confining layers and the aquifers look like. So this near surface aquifer here is sort of the it would be the the COBI aquifer. That would be this would be the perched and semi-perched aquifer here.
So yeah, so you're using some terms here which it might be helpful to describe. Perched, semi-perched, glacial marine, if you could explain that a little bit.
Okay, yeah, so a perched aquifer is perched on top of a confining layer. So it has a confining layer underneath it, which is fairly impervious. So the water is actually perched on top of that near the surface. Same thing sort of for semi-perched. Sea level means that the water table level is close to sea level. Glacial marine is a special type of aquifer that has to do with being near a saltwater influence. Fletcher Bay is a deep aquifer on Bainbridge Island, and then there's a bedrock aquifer over in Fort Ward area, which of course bedrock. The only water coming out of that is from fractures, cracks in the bedrock, so it's not real productive.
And it sounds like we have examples of all of those on our island.
So yeah, we do. Yeah, right. So this one on the surface where the pointer is right now, that's the perched and semi-perched. The water table's at an elevation of 0 to 300 feet above sea level. And then you have QA1, which you can see right here. That's the sea level aquifer. So the water table levels on sea level aquifer are between -200 and +200 feet above sea level, above or below sea level. And then the next one down here, the blue, the QA2, is the glacial marine aquifer, which is 500 to 300 feet below sea level. And finally, the deep Fletcher Bay aquifer, which has the top of that aquifer is anywhere from 900 to 600 feet below sea level, and then the bedrock below that. 97% of the pumped well water on Bainbridge comes from the perched, the sea level, and the Fletcher Bay aquifers. So very little from the bedrock, the glacial marine, or the semi-perched. All the recharge water for these aquifers originates on the island, except for about 5% that flows underneath Port Orchard Bay from the Kitsap Peninsula, and that contributes to the sea level, the glacial marine, and the Fletcher Bay aquifers. But again, it's only about 5% of the supply of water to the aquifers. The other 95% comes from rainfall falling on the island. And water quality in general on the island is very good, and in general, it's not a problem for all the beneficial uses that it gets put to. Well, I'll mention here that our power went off for most of yesterday, about 12 hours, and of course, when you're putting together a talk, that's the most crucial time, because the day before is when all the tweaking gets done, so that couldn't really happen. But this is a kind of a blurry image of a slice going from west to east, which this basically on the left here is Silverdale area, Clear Creek, and on the right is Puget Sound, and here's Port Orchard Bay, and this is Bainbridge Island right here. So this cross section cuts right across here. So sort of across, I guess that would be about Battle Point or so, or maybe a little south of Battle Point. Yeah. So here you can see the connection of some of those deeper aquifers. Here's the sea level aquifer, which sort of pinches out here. There's this blue underneath Port Orchard Bay, so it's not, in this case, connected to the sea level aquifer on the Kitsap Peninsula side. But here, the darker blue right here, this is the glacial marine aquifer. which you can see goes underneath Port Orchard Bay and is connected to the glacial marine aquifer on the Bremerton side of Kitsap Peninsula. And then the deeper one here is the Fletcher Bay, and it's also connected. So that's where that 5% of off-island flow can come from. Okay, so let's see. Another thing about Bainbridge Island aquifer is that it's considered a sole source aquifer by the U.S. Environmental Protection Agency. And this definition means that it supplies at least 50% of the drinking water for the area overlying the aquifer, and for which there's no alternative source which could physically, legally, and economically supply those that depend on the aquifer. This sole source designation can affect federal funding for any project with the potential to contaminate the groundwater. So basically the groundwater on Bainbridge Island, since it's considered our only source of drinking water, has special protection from contamination that if it were not a sole source aquifer, it would not have.
So when we talk about that, is that a combination of the Fletcher Bay and the perch that you were talking about before, or is it basically the Fletcher Bay aquifer that is seen as the sole source?
This is all 6 aquifers on Bainbridge Island. So the entire groundwater supply on Bainbridge Island is considered sole source. Yeah. So it could be read as sole source aquifers in this case. But in the EPA designation, it talks about basically an aquifer as the total of groundwater in a groundwater basin. So ETAC as a committee believes that Bainbridge Island should have the goal of being self-sufficient with respect to water resources. In other words, that we shouldn't really consider a pipeline across the Agate Pass Bridge or desalination of seawater. And those were also looked at by EPA in their designation. And the Agate Pass Bridge was considered to not be sort of economically or politically feasible, potentially. And desalination currently is very expensive, and unless you have a good renewable source of energy providing your energy, it's kind of a losing proposition relative to climate change and our carbon footprint, because it requires a lot of energy. So the groundwater fact sheet that we're working on was given the approval by City Council almost a couple of years ago now. For us to develop this, we're about ready to send it out to review by Kitsap Public Utility District and USGS groundwater hydrologists to get their input, make sure that we're not putting out something that sort of misrepresents the science of groundwater on Bainbridge, since they're the main 2 entities in addition to Aspect consultants on the island. Basically, it's not being reviewed by them because there would need to be a source of funding to pay them for their review, and we don't really have that as part of developing the groundwater fact sheet. So we're going for the reviews by the public agencies. So it's going to be a 2-page front and back, so basically a 4-page, and it's going to talk about some of the things that you've just seen here and what you will be seeing in this talk. Okay, so next I'm going to introduce the model that USGS developed of Bainbridge Island back in the report was published in 2011, so about 9 years ago. The report came out, which in this case was a model just of Bainbridge Island as a separate entity from Kitsap Peninsula. It's a mod flow model, which is the most commonly widely used groundwater model basically around the world these days. It was developed by USGS. It's because of that, it's in the public domain. For the Bainbridge model, let me see, the horizontal grid size. So feel free to ask questions anytime when I'm talking about these details about modeling. But in hydrological modeling, you basically split up your area into small grid sizes, and you do basically water balance within each of those grid sizes, and then that moves on to the neighboring grids around it. So for the Bainbridge Island model, there were 193 columns wide, the width of Bainbridge Island, so representing, you know, that roughly 5 miles wide of Bainbridge Island, and 197 rows representing like the roughly 10-mile length of Bainbridge Island.
So that mod flow refers to cutting it up into modules.
Yeah. So yeah, I think that's probably what the mod does stand for. It stands for modular. It's a modular type of modeling where it breaks it up into smaller segments and then aggregates that into a larger area. Yeah. So each one of the horizontal grids, if you're flying on an airplane looking down on Bainbridge, is about 800 feet by 800 feet. And then it also has like the wedding cake layers, has 33 layers from land surface down to bedrock, representing the different sorts of soils and confining layers and aquifers going from the surface down to the bedrock. The inputs to the model are monthly precipitation, the soils information, the superficial geology, the surface soils, surface water features, stream flows, wells, and monthly pumping, and measured water levels, which the city and KPUD measure over 100 wells on a monthly basis on Bainbridge Island. So that information goes into as a model input. And the model output is simulated monthly water levels. So basically, you see how well the model is doing by how well do the predicted water levels match up with the measured water levels. So your water levels in the wells becomes your calibration, which you can then tweak your various model inputs to try and get a better match for that output of water levels. And this shows that grid I was talking about of the 800 by 800 foot cells, if you're looking straight down on Bainbridge Island here. Couple things to point out here. Here in blue here is Gasm Lake. And Gasm Lake is represented in the model as a general head recharge. So it's basically sort of a constant recharge area. So there's always a little bit of surface water in Gasm, which is recharging the groundwater below it. So that's how Gasm's represented. Cells that are bordering surface water, streams, and the coastline, you see mostly blue along the coastline wherever there's a stream. Those are specified as drains, which is where water flows from the groundwater to the surface water. So the water from the groundwater is surfacing to either the coastal waters or to a stream. And this particular one shows the surface. So this is the very top layer. So in this case, it shows the presence or absence of the Vashon Till, which if people have heard about that, it's sort of a combining layer, which is of sorts on the surface, which is found throughout a lot of Bainbridge Island. You can see the present here is sort of the yellowish color is where it's present, and the orangish is where it's not. So it's present throughout a lot of the island, and it sort of inhibits groundwater infiltration.
So is Vashon Till something that came from the glaciers?
Right. It was what was left from the glacier. So it's the fine materials on the surface that were left from the glaciers going across, creating Bainbridge Island. Yeah. So what kinds of questions can groundwater models be used to address? So this is a slide I pulled from USGS, the author of the report, Lana France, who's with the Tacoma office. So one question is how will saltwater intrusion affect coastal wells? So that's a question that can be put into the model, and you can get sort of a projection, a modeling projection on how much saltwater intrusion will affect wells if you make certain changes going into the future, like more pumping, less pumping, more or less recharge, various ways of augmenting recharge, like stormwater reuse, wastewater treatment reuse, etc. How are surface streams likely to respond in the future? So the perennial flow in surface streams on the island, I mean, you'll see flow in these streams in the summertime when it hasn't rained for quite a while. And that flow is obviously not runoff from the most recent rainfall, which may have been a month ago. It's where the groundwater intersects the surface water. So that's groundwater that's supplying that surface flow. But if the groundwater level falls just a slight bit, that surface stream will dry up because you no longer have that connection between the groundwater and the surface water. So you can see how surface streams will be affected in the future, say if you have more groundwater pumping. How much drawdown can be expected in the water table with changes in pumping or recharge? How will all these variables be affected by seasonal variability? What are recharge areas and travel times to specific wells? So these are all the kinds of questions that can be asked with of groundwater models, and they can provide an answer. It's not a definitive answer because it is a model and it has various assumptions and it has a certain amount of uncertainty. But these are the types of questions that models can't address since it's an 800-foot by 800-foot grid, and it can't tell you what's going to happen to my well. It's not fine enough detail to tell you exactly what's going to happen on your piece of property and to your well. It doesn't answer political questions, such as what's the best growth scenario. It's a scientific model, not a.
That's unfortunate. I figured that everything was a political question these days.
Yeah,
but...
I know. Yeah, it'd be nice if it could answer those for us, but that would have to be put to the people, I suppose, or at least the city council. And it can answer questions like, where would be the best place to put a new well? You need one of those sticks to tell you that where to put a good well, right? What's dosing sticks? Yeah.
Yeah, diviner rods, exactly.
Yeah, those things, yeah.
Does this model help me understand whether or not rainwater recharging our groundwater? So if we have rainwater mostly recharging our groundwater, why would we ever run out of water? Because we have so much rain on Bainbridge. Why would we run out? Does this model help us?
You know, I'm going to get into that in a minute when I talk about where the water goes. And when we talk about a water budget, which is coming up in one of the next slides here.
Oh, okay.
So we can sort of see all the various components when the rain hits the ground. Some of it goes to the groundwater, some of it runs off, etc. So yeah, that will be easier to talk about when we talk about water balance. And here we are, water budget analysis of Bainbridge Island.
I really didn't know.
Excellent transition, Alyssa.
Yeah, good job. Boy. Okay, so on the most basic sense, a water budget means inflows to the groundwater system minus the outflows equal a change in storage. And that change in storage would show up as a change in water levels in the wells. So the inflows are recharged from precipitation. So that makes up 85 to 90% of the inflows to the groundwater system. Recharged from septic systems make up about 5 to 10%. And then that off-island aquifer flow to Bainbridge Island underneath Port Arthur Bay from Kitsap Peninsula, like I mentioned earlier, it makes up about 5%. And the outflows are groundwater pumping, which is only 5 to 10% of what is taken out of the groundwater supply on an annual basis. I think for Bainbridge Island, it was in the model, it came out about 7%, but that's going to vary annually with pumping and with rainfall changes and seasonally. For Kitsap Peninsula as a whole, it's about 4% based on a more recent modeling by USGS. So where's the rest of that water go if it's not being pumped out? So like I mentioned, a lot of it interacts and creates perennial flows on the island, and by the groundwater table intersecting the bottom of the stream flow channel and discharging groundwater to surface water. That makes up 50 to 60% of where the groundwater outflows go. And the other 30 to 40% discharges underneath Bainbridge Island to Puget Sound. And this discharge helps to repel that seawater intrusion and keep the saltwater freshwater divide farther offshore. So if this were reduced, the saltwater would start coming in more, and you'd have more concern over possible seawater intrusion. If this number gets reduced, you would start seeing some surface waters, perennial surface waters, drying up in the summertime. So change in storage, like I said, is reflected. It's calculated from changes in water levels. So the question was about rainfall and what happens. I mean, how can we ever run out of groundwater since we have so much rainfall on Bainbridge Island? And I guess the answer is all it takes is a small tweaking of things. So if you increase the pumping by 10%, 20% with population growth, say for some reason we go back to more agriculture on Bainbridge Island, not likely at this point, but that would require more water than say a housing development might. Anyway, if you increase pumping, it could lower that water table, and a small amount would make a change to the discharge of surface waters and also a discharge to Puget Sound. So what can the model's water budget tell us? So this shows from a more recent USGS model that he did of the entire Kitsap Peninsula. This sort of variation in recharge, this shows you the order of magnitude between recharge and storage in the aquifer, stream flow coming from that groundwater. Wait, it's probably stream flow total, yeah. And pumpage, groundwater pumpage. So on the top here, you see the recharge, and you know what was it? 85% of it comes from 85-90% comes from rainfall. So that's the amount of recharge, and this is the amount of groundwater pumping, which I said was like 7% of the recharge. And the stream flow here is, although larger considerably than the pumpage, it's still a lot less than the recharge. And final, this is the change in storage, which is affected by change in water levels. So here you can see that there's a huge variation from year to year in recharge due to precipitation changes from year to year, which are very significant. And that affects the storage, the groundwater and storage on the island. But the stream flow and the pumping are fairly consistent relative to those two factors. And you would see again that stream flow would start dropping off precipitously if there were a reduction in that recharge over time. So the USGS played a couple of scenarios, sort of what if scenarios, to see what would happen in the future. Again, this was the future in this case was sometime after 2012. If recharge were decreased by 15% on an annual basis, how would that affect the base flow in streams over time? So here you can see the stream flow, which has a seasonal component. So the base flow would be, well, the base flow, where the only flow in the stream is coming from the groundwater, is occurring in the summertime. And then the rest of the year you get more flow also coming from the groundwater, because groundwater table would be higher with the rainfall recharge seasonal basis as well. But the overall change in stream flow with this 15% decrease in recharge would be 18%. So it's pretty much a direct correlation between a direct linear one-to-one relationship between recharge to the island and the stream flow over time. So if you reduce the recharge, you're reducing the stream flow by that much. Whereas water use, reflected by groundwater pumping, if you reduce outdoor water use by 80% during the summer, this would have just a relatively small effect on the overall stream base flow on the island. So if you have slightly higher groundwater levels created by this 80% reduction in pumping, but again, pumping is a small percentage of the recharge, so it has a relatively small effect on the water table compared to recharge. It only has a 0.5% increase in stream flow by reducing the pumping in the summertime. So there's a lot of information on this slide. Looking at this so even though the aquifers have confining layers between them, there's always some flow that gets through that confining layer. So over time, eventually there will be some movement through confining layers in a vertical sense, a lot of movement horizontally to avoid the confining layer, but there's also movement through the confining layers. So this shows in green here is the recharge. This is in 1,000 acre feet per year. It's a unit that engineers use a lot. It's basically an acre foot is where you have an acre of land 1 foot deep in water. So that's the volume of an acre foot. This is thousands of acre feet, but you could call these gallons, billions of gallons in any unit. The important thing is sort of the size of that. So recharge to the surface, to the perch aquifer here, 3.1, and then recharge directly to the sea level aquifer, 0.4. That's because the perch aquifer is not laterally continuous. So there's places where there's no perch aquifer and the recharge goes directly to the sea level aquifer. And then groundwater flow here is what's flowing through the system. This is on an annual basis. So you can see groundwater flow to the perched aquifer and then through the perched aquifer to the sea level aquifer. And this the red is the amount that's taken out by groundwater wells from each of these aquifers. So you can see from the perched aquifer, you got 0.3. There's more taken out of the sea level and the Fletcher Bay aquifers by groundwater wells, and very little from the glacial marine. And in the purple here is outflow from that aquifer to Puget Sound. And in the orange is outflow to a surface water stream. So, of course, you don't see those in the lower aquifers, only in the ones which are near the surface, which could intersect a stream flow, a stream bed with the water table.
So can I just ask for a reminder here that when you talk about recharge, because of the slides you showed earlier, that is almost entirely rain. Is that right?
Right. 95% of that's rain. A small amount of that is from people's septic tanks. Right. And in the yellow is recharge coming in laterally underneath Port Orchard Bay, that 5% of recharge coming from Kitsap Peninsula. So this is basically a water budget accounting for movement through and between, in this case, 4 different of the 6 aquifers on Bainbridge Island.
And at least for the top 2,
right.
Those groundwater or rain is going to be a real big part, and we know that's really variable.
Right.
And I'm guessing that there's a difference between big rain events where we get a lot of rain in a short period of time and our traditional 9 months of drizzle. Right.
So when you have a strong rain, lots of it is going to run off as surface water, not infiltrate, just by sort of the physics of it, because the soils on surface will reach saturation, and after the sponge is saturated, the rest is going to run off into Puget Sound. And that's something that's being considered as sort of a change that could be made to the system to keep more of that storm water on the island and less of it running off to Puget Sound, because it would be good to have that to recharge the aquifers more. Yeah. And that's something that is projected to change with global climate change here. I mean, the projection is that we're going to have similar annual amounts of rainfall in the future, but fewer but more intense storms and sort of a more narrow rainy season. So we'll have a longer, warmer, drier summer season, but a winter season with more intense rain, but overall about the same amount of total rain. But again, with more of that coming in intense storms, more of it's going to be running off, less will be infiltrating.
Charlie, do the people that are concerned about the ocean life, are they concerned that we might try to hold on to the water and not share it with the ocean salinity levels?
Well, I mean, immediately it's pretty small impact that.
But what if all the islands and all the communities that
all the communities near shore.
Everybody started holding on to their water. Are the ocean people, the people that are concerned about salmon, et cetera, are they chiming in to say whether or not they think communities should hold on to their water and not let it drain into the?
I haven't heard that being a big concern, at least okay. as of now. Yeah, I mean, I think relative to the ocean and Puget Sound, these numbers are all really pretty small, and it would, yeah.
Okay. Thank you.
Okay. So lastly, I'm going to talk about a Bainbridge Island Review article from 10 months ago now, close to. I don't know if anyone out there saw the article. It's front page material, but it was again at Christmas time, so it could have really.
It looked like there was nothing to worry about.
Everything's fine, right? Which was unfortunate that it went out there basically uncontested. The city had a brand new public works director at the time, and he didn't really have time to deal with it, and it was at Christmas time, so probably a lot of staff were gone. So there was no one from the city commented on it, and they got a couple quotes from a geologist at Aspect. I guess the hydrologist and hydrogeologist must have been on Christmas vacation, because the person they talked with was a straight out structural geologist, not a hydrologist. Anyway, this was the title of the article was "Confusion Runs Deep. Oft debated islands water supply is stable, ample according to latest research." And here's some of the misstatements, misleading statements, and questionable quotes that were in the article. And it was never clear who the experts were. People say, I guess. People are talking. The science simply doesn't support worrying about water, experts say, was one statement made. In fact, these wells are, and then in red, shown not to be decreasing in volume at all. This was, yeah, I believe from Aspect. And actually, you don't look at the volume in a well. You look at water levels. I mean, you can't really see the volume. You can keep pumping it until the water level drops below the your groundwater, your pump level. So you wouldn't see any changes in volume, because the volume that a well can take from can be a pretty sizable area that contributes to that well. So the real statement should be whether or not water levels are increasing or decreasing over time, and whether you're seeing a long-term trend in those, not whether there's a change in volume. Groundwater
volume would then be presumably measuring how much we're able to pull out at any time, and
right.
It seems like as long as there's water in the hose, there's water in the hose.
As long as there's water in the hose, you can turn it on and get water. Yeah.
Until the point at which it drops below, the water level drops below the point at which the intake valve is, and then you get nothing.
Right. Then you're sucking air. Yeah. Yeah. So again, that was a misleading statement, but groundwater recharge is not going to help or hurt our deep aquifer. And to be honest, I don't know that it's going to change the likelihood of shallow wells drying up. Well, I don't know if that was a correct quote, but that's what showed up in the paper from the geologists. To say that groundwater recharge doesn't have an impact on shallow wells is ludicrous, because it's the reason shallow wells are there. Without recharge, all the wells would have dried up, and especially shallow wells, because they respond quickly to rainfall versus the deeper wells. The deeper wells depend on the movement between the aquifers and through confining layers, but the shallow wells are directly tied to groundwater recharge. So, and then this last one, I think there are so many people on the island that are claiming that we have a water shortage, that the way to do it is to hire a hydrologist, because I think that there's not a backbone in the city to stand behind the USGS report and the 2 studies that Aspect have done since then. I look on hiring a hydrologist as probably, you're talking more than $250,000 for something that really doesn't. And then the person concluded, I don't even know what they're going to do. So anyway. So I guess I'm finishing up here with a couple findings that from Aspect and some findings from USGS that are kind of important on what happens, at least what model projections say would happen in the future with various scenarios of development on the island. So Aspect made 3 simultaneous changes to the USGS model. They were paid by the city to run various scenarios of the USGS model, and in one they increased groundwater pumping by 50% to project increased development over the next 40, 50 years. They reduced recharge rates by 20%, which sort of takes into account that climate change impact, where more of the storms are going to be intense and more is going to run off to Puget Sound and less infiltrate into the aquifer. And also the change in climate with warmer, drier summers. And they also looked at an increased sea level by 4 feet to look at change in sea level rise with climate change. So after running a 100-year simulation, they found the following changes in the water budget. They found a 40% decrease in groundwater discharge to surface waters, so that the water table would be reduced enough in the perched and the sea level aquifers to cut down on some of the interactions between groundwater and surface water, which would make a 40% reduction in the groundwater base flow to surface waters. They found a 40,
which is like streams that support the salmon, for example.
Right. In some cases, yeah, the perennial streams. So it would be saying that a lot of the perennial streams would be drying up in the summertime because of that. Yeah. And also wetlands, that where the water table intersects the surface to create a wetland. So wetlands could be drying up as well. And there'd be a 24% decrease in groundwater discharge to Puget Sound. The thing that Alyssa was talking about. So that would be happening here. So you'd have less fresh water going out to Puget Sound. And there'd be a 34,000 acre foot reduction in aquifer storage. So it'd be a slight reduction in the water table in general across the island. And Aspect recommended that these and other future assessments take into account that these various things be done in the future to refine the groundwater model to better zoom in on that groundwater interaction with surface waters. So next time that they do a model scenario, they would refine the model wherever there's a surface water connection with groundwater to get a better handle on what's happening there. That they would provide periodic model updates, looking at new wells, new pumping data, new water level data, that could be incorporated into the model to come up with better projections over time, and continue to implement the cities and also KPD's groundwater monitoring program to provide them the data that goes into the model. So some select USGS findings, recharge amounts have the largest impact on base flow discharge and groundwater levels. Much greater impact in pumping rates, as recharge makes up 95% of the input to the system, while pumping is only 7% of the outputs from the system. And this from a USGS report that not all natural discharge in the model area is to Puget Sound. A large quantity of groundwater discharges to streams, lakes, springs, and seepage faces. And then in red is sort of the take home from that is that the magnitude of potential groundwater development therefore depends on the hydrologic effects on discharge that can be tolerated. So that's basically saying that it's sort of up to the people of Bainbridge Island to decide what they're comfortable with as far as impacts on the quote unquote natural system, I guess.
So I wonder if you can turn that into something more English for those of us who are the magnitude of potential groundwater development.
Okay,
depends on the hydrologic effects on the discharge that can be tolerated.
Okay, so this is basically saying the amount of development happening on the island is the main thing that causes more groundwater development, i.e. groundwater pumping. And so the more groundwater pumping there is in the future, the more that's going to impact streams and wetlands and springs and seepage faces on the island. So those will start disappearing in the summertime if growth reaches a certain level where you start seeing a reduction in the water table, so that those surface water features are impacted. So that's something where, you know, if the city of Bainbridge Island people or the council decides that drinking water is the only thing that matters, then that would not impact people's consideration of development.
So the first level of knowledge here is that it seems unlikely that human drinking water is going to be affected in the short term based on the work you've done and the work that Aspect did and the information we got from USGS. But right away, we're going to start to see through development problems with the wetlands and the streams. Am I reading that correctly?
Right, right. Got it.
Okay, and I know that we're running short of time. I want to make sure that if somebody does have a question, they have an opportunity to speak. And Ben Harrison, who was also on the committee, is here. So if you want to pipe up, we'd love to have you introduce yourself.
Hi, I didn't want to necessarily take away from anything that Charlie is saying. For that matter, he is far more has far more of a background on hydrology than I do. I just thought that I would add to Charlie's answer on the stormwater retention point that in addition to increasing the amount of the degree to which the island retains stormwater, that isn't necessarily in and of itself doesn't change the water budget of Puget Sound much, but on a case-by-case basis of where you're retaining that stormwater, you can change the surface water, the stream systems in a way that does impact marine life. And that stormwater events also change the water quality in the stream systems on the island. So as you're talking about marine life around some of these stream systems where they interact with the sound, then that is a consideration on the overall health of the environment on a case-by-case basis. But that's not really a broad Puget Sound issue. That's a question of keeping up the health of the wetlands and the stream systems.
Right, and there's lots of wildlife that interacts, marine wildlife in estuaries and in areas where salt and fresh water mix. And if we're reducing the amount of outflow, it's going to change those places dramatically.
Yeah. Thank you, Benjamin. Benjamin's our latest member of ETAC, just joined us. He's a geochemistry background, and great to have you on ETAC. Hey, do I have just a couple minutes to?
Yes. I
just want to say one last thing about what the city is doing. In addition to having us develop a groundwater management plan, which is kind of a standard process. It's like a 2 to 3 year process once it finally gets going here, which is to sort of set the goals for the community on what we want our groundwater system to look like and to provide for us in not just drinking water, but in other ways. So that's something that's coming up. 2 things that the city has done on the issue of trying to keep more recharge on the island, in addition to the, defining the entire island as a critical recharge area. They also recently funded a couple studies. One is to look at what it would take to improve the wastewater treatment plant. I know that's right there in your neighborhood, Reed, but it would, and it doesn't have a lot of land, but they have a study to look at what it would take to improve the treatment up to tertiary level to remove some contaminants of concern. And by doing so, it would allow for a lot of that to be recharged back to the groundwater instead of discharged out into Puget Sound the way it is right now. So that's one potential way of increasing recharge on the island. Another one is a study that they are going to be putting out for bid here shortly, which is to look at ways to keep more of the stormwater on the island. So instead of having that run off into Puget Sound as well. So that'd be a combination of looking at ways to reduce the velocity of the stormwater and create holding areas for it, and ways to filter it out to maintain water quality that would be sufficient for recharging the groundwater. So that'd be another way of increasing the recharge part of the equation.
Okay, thank you. And we're a little over, but I want to make sure that if anybody else, I see both Bonnie and Jim have their microphone open. If either of you have a question, please.
We have, I do have one question. We have at Islandwood probably one of the state-of-the-art water recycling operations that reclaims solid waste. And where are we going with this kind of thing? Let's utilize get rid of these septic fields and put in state-of-the-art water recycling.
Well, I mean, probably one of the best things as far as, Matt, sort of hate to say it, because by having everything sewered, you're also creating a way to increase development. But if everything were sewered and could go to a centralized location for water recycling, that would be an improvement over having septic systems where there's not that much filtering going on, and a lot of nutrients, nitrate and whatnot, ends up making it down to the groundwater level. So septic systems not really ideal. And if that could go to a water recycling area or to a treatment plant that's then tertiary, which then gets reused to recharge groundwater, that would be a better way to use that resource. Yeah.
Thanks, Charlie. You've answered my question. It makes a lot of sense to me as well. So I appreciate that. And the presentation was terrific. Thank you very much.
Thank you.
And Charlie, I want to invite you to come back. I appreciate you being a member of the Senior Center. Senior Center membership is just $20 a year, and it supports programs like this. And we're just now in renewal time. So if you are not a member and you join today, you'll be a member through December of 2021. Look at that, a couple, 3 months. What a deal.
What a deal.
Anyway, Charlie, I want to invite you to come back as the city continues to work on this, and Benjamin as well. We really appreciate getting a better understanding of sort of all the factors that are at play here.
Yeah, I'd like to put in one last plug for ETAC. If anyone themselves or they know someone who's a scientist of some sort related to environmental issues and they're interested in volunteering to be on ETAC, we do have 2 openings right now.